Hey guys, welcome back to a new video. In the last video, we looked upon the hydrogen spectrum. We did discover the energy levels, the orbit, K, L, M, N, and all that. So, uh, let me tell you a point that this energy that is radiated, is kind of studied by Max Planck as well. There it is a short point that is these energy was also studied by Max Planck Max Planck, and what he just said is that uh, he said that this energy is released in the form of quanta or quantum. He has given his own equation, but I'm not going into that. I'm just giving you a concept that is, he said that is made up of energy particles that are termed as quanta or quantum photon. Okay, so in the today's video looking into the more concept, like we have discovered this thing. Till now we have discovered the orbits. Now what happens next? uh, Let me use this slide to make you understand the thing. So in today's video, uh, we are working on the in this, let me say a thing that in this we discovered orbit like KLM, and we did got to know about this. If you haven't checked this previous videos, do check that out. We are making a type of a story to learn all this, and the story breaks if you have missed a single video. In today's video looking into, I'll making a section in between this, like over here I'm making a line to separate this. I'm just not using a different slide because that would be confusing maybe. So uh, we'll today we'll talking about uh, suborbit. Like when this orbit got discovered, then we have got the suborbits. Now what we did, uh, the energy, or according to Max Planck, the photons released, the photons released were passed through spectrophotometer, and we found that uh, this energy further consists of different different energy states. Now let me make you understand what it says. First of all, we have got this thing, like we have got this energy, right? What we do now is that we have got a device, uh, for suppose this, and from this what is going to happen is that, for suppose this is termed a spectrophotometer. I am writing spectrophotometer, SPM. Do you understand this? SPM means spectrophotometer. So when light was passed through it, when this for suppose uh, this is orbit M has got 18 electrons, right? I'm taking a big number to make you guys clear in a a single shot. uh, we take M18, so we have seen that energy is radiating into it. Now when this energy is passed through this spectrophotometer, what spectrophotometer is a kind of device that splits energy, or it analyzes energy, I'm not known that much about that, but it has done something good. And we have got when this energy. Okay, sorry, that would be confusing for you. So what is happening is this: when this energy was passed into it, like when this energy got passed into it, uh, it further broke into parts over here, like further broke into parts like this. Some were this, some were straight, some were this, big deflections, some were like this. So here we've got some sort of difference from the energy radiated. This is the energy radiated, and we did analyze this energy radiated by the excited atom. We further found different sort of energy levels, and when we did analyzed it, we've got four different uh, you know states. Like uh, some were sharp like this, some were sharp, and um, some were principal. Let me make them like this. Some were principal and some were diffused like this, and some were highly complicated like this. We can do whatever you want. So what we do analyze from here is this: like this one was some energy, some energy released was said to be having. So how can you say that we've got shapes? Like you've seen that spectrophotometer is also present in hospital. We've got shapes on it, like lines, different. That is the same. So this is the same concept which is being used. You need to connect the both. So this is a sharp, this is a sharp, this is uh, some lines were found to be sharp, and some were found to be principal principal in shape. Some were found to be diffused in shape, and some were found to be highly complex, fundamental. So I do hope that you got an idea what we are going. So this sharp word named to be as s orbital, and this principal was named to be as p orbital. This diffuse were named as d orbital. Sorry, this is not orbital. This is suborbit. Sharp is s suborbit. Principal is p suborbit. Diffuse is d suborbit. And highly complex is f suborbit. And we have got particular we did check this analysis, and we've got that it is consisting of energy, and we'll looking into deep into this one of each. And I'm not talking about how many this is having, how many electron and all this is having, like talking I'm just giving a concept. Like till now you need to know that this is having maximum 2 electrons, p is having 6 electrons, diffuse is having 10 electrons, and the highly complex is having 14 electrons. So as the electron number increases, the complexity also increases. So I do have that got that we have discovered suborbits in the previous video, discovered orbits in the next video looking into orbitals. So I do hope that you got today's concept. Meet you guys in the next video. Till that, goodbye.